All right, this is grade 6, unit 2, lesson 7. And in this lesson, students are going to continue their work with that double number line as a really powerful tool for understanding equivalent ratios. In this lesson, the students are going to be responsible for creating these double number lines from scratch and then using that initial information that they're given to create other entries on that double number line. So let's get started.
So we're going to start off with a warm-up, and it says ordering on a number line, and we're supposed to locate and label each of these following fractions on our number line. So we're going to notice that our number line starts at 0 and it goes up to 2. And just as just a frame of reference, that means halfway must be 1. So where is a half going to be? It's going to be halfway between 0 and 1. Where is a quarter going to be? A quarter is going to be halfway between 1 and a half. And then where is 1.5 going to be? Well, that's going to be somewhere between 1 and 2. So that means 1 3/4 is going to be way over here between 1 1/2 and 2, right? And so that's going to be way over here, 1 3/4. And then lastly, where is 1.75 going to be? Well, it's going to be in the same exact location because it is the same as 1 3/4. Then it says, based on where you place the numbers, locate and label 4 more fractions or decimals on the number line. So parents and teachers, we're going to allow students the opportunity to just be creative and place 4 more fractions or decimals on this number line. So we've got the other day, we made green water. Cute little story here by mixing 5 milliliters of blue with 15 milliliters of yellow. So there it is. There's our ratio right there. 5 ml for blue and 15 ml for yellow, because there's our labels over here. We want to make a very small batch, so we're going to want to continue and do all these tick marks down here. So if I'm thinking about this ratio, that relationship between blue and yellow, I can see that the ratio, I can imagine that for every 1 blue, there must be 3 yellows. And let's see if that kind of works out to be true. So for every 1 blue, there are 3 yellows. Let's see, so if we have 2 blues, that means we're going to have 6 yellows. If we have 3 blues, that means we're going to have 9 yellows. And if we have 4 yellows, that means we're going to have 12 yellows. 4 blues, then we're going to have 12 yellows. And so you can see I had to put in the tick marks for the yellow. I did not have to do that for the blue because they're kind of starting to scaffold this for our students. Number 2 says, on that number line for yellow water, draw and label tick marks to show the amount of yellow water needed for each of the blue. So there you go. And so I guess I did both question 1 and question 2 at the beginning. All right. So number 3, how much yellow water should be used for 1 blue, 1 milliliter of blue? So if you have 1 milliliter of blue, how much yellow? That's going to be right here. And I can see that if we have 1 ml of blue, that means we're going to need 3 mLs of yellow. So it's going to be 3 milliliters of yellow. And then question 4 says, how much yellow water should be used for 11 milliliters of blue? Uh-oh, we don't have that, do we? So we're going to have to go up here and we're going to have to think about our double number line because we need to keep going, right? So for every 1 blue, we're going to add 3 yellows. So if I add a blue, so that's going to be 6, 7, 8, 9, and then 10. So 6, 7, 8, 9, and then 10. And then down here, we're going to have tick marks for our yellow, yellow mLs. And then so for every, remember, for every one blue that goes up, we're going to add 3 yellows. So I'm going to kind of zoom in a little bit here. Ooh, whoa, I'm going to zoom in a little bit here so that we can mark our yellows. So we're going to keep adding by 3. And then so if we go up to 11, this one goes to 11. 11, so we've added 1 more. So what are we going to do down here? We're going to have to add 3 more, and that gives us 33. So question 4, how much yellow is needed for 11 blue? Well, we're going to need 33 ml for our yellow. And then how much yellow should be used for 8 milliliters of blue? So if we're doing this one right here, how much yellow for 8 milliliters of blue? Well, all we have to do is go up here. We have to look and notice that there's our 8 milliliters of blue, which means we need 24 milliliters of yellow. 24 milliliters for yellow. And then why is it useful to know how much yellow water should be used with 1 milliliters of blue? Well, this is kind of a cool little question here, right here, because once we know that smallest, in this case, kind of like a unit ratio, that's going to help us with our multiplication. Because once you know this guy, all these other ratios, these equivalent ratios, can be found through multiplication rather than addition. Because we can see that, and I'll do it a little thicker there. For example, to go from 1 to 8, we multiply by 8, which means to go from 3 to this number, 24, we're multiplying by 8. So if I wanted, let's do it in green. If I wanted to multiply by, I don't know, 15, that would give me 15 mLs for blue. And what am I going to do down here? I'm going to multiply by 15, and that's going to give me 45 mLs for the yellow. So that knowing that smallest, well, they're all equivalent ratios, but knowing that ratio that uses the smallest numbers is helpful because it's going to help us multiply to create all these other equivalent ratios. So that's actually, boy, that's a thoughtful question. I love that. So here they are asking us, they're telling us that there's this recipe that for every 2 pints of water, you're going to have 8 cups of flour. So there's your recipe for this art paste. And these are all the directions that tell us how to create a double number line for this relationship. And they do want us to identify that the first line is water, the second line is flour. And then they want us to go and design it. So let's do it. So I'm going to get my little, there's one number line and there's another number line. I'm supposed to be trying to make it as straight as possible. Here's my water, here's my flour. I'm going to start them both off at 0. And then 1, 2, 3, 4, 5, 6, 7, 8 is my water. 1, 2, 3, 4, 5, 6, 7, 8 is my water. I'm going to have similar tick marks down here for my flour, but what are my numbers going to be? Well, we know that our very beginning, way up at the very top, right here, we are told that for 2 pints of water, we're going to have 8 cups of flour. So that's right here, that when this is 2, that this is 8. So automatically we can start to fill in the rest of the table. Well, if you have half as much water, you're going to have half as much flour. And now we can start to see that for every 1 water, we're going to have 4 flowers. Add 1 more water, you're going to add 4 more flowers. So these are going up by 1s, so these are going to go up by 4s. 16, 20, 24, 28, 32. And we're starting to see patterns all over the place. All right, so continuing, along with, okay, there we go. Good enough. All right, so now number 2, it says compare your double number line with a partner, okay, and because there are ways that it's possible for your double number line to look different from a partner's. So parents and teachers, we are going to want to have students compare so that they get a sense of what can be different and still be correct versus what is different, but that's because it's wrong. So moving on to question 3, now use your double line number line to answer some of these questions. All right, so let's do it. So first one, how much flour should be used with 10 pints of water? So we're going to go up here and we're going to look. And we see that, I did not go up to 10, did I? But a couple of ways I can answer it. One, I can see that the relationship between the water and the flour is that whatever the water is, the flour is always 4 times as large. And so we got 4 times 4 is 16, 5 times 4 is 20. So if we want 10, 9, 10, so there's 9, there's 10, we automatically know, just multiply, extend this, multiply it by 4, and that's going to give us 40. So we know it's 40, but we can kind of continue and say, well, add by 4, that gives us 36. Add by 4, that gives us 40. So a couple of different ways to discover that the answer is 40. And I can't remember, was it 40 what? 40 teaspoons, 40 cups, what is it? Oh, it's 2 pints of water for 8 cups of flour. So, so that's going to be 40 cups of flour. So then it says how much water should be used. Oh, come on. There we go. How much water should be used with 24 cups of flour? So imagine you're going to have the number 24 way up here. So I'm going to do it out of proportional, it's not to scale anymore. So we need this number to be a 24. So if that number is a 24, what would be the number down here on the second number line? Well, whatever the heck 24 times 4 is. So I need to do 24 times 4 because I see that the relationship between the water and the flour is always by multiplying by 4. So now we're looking at this relationship instead of the horizontal relationship. So I'm looking at the vertical relationship. And down here, since 24 times 4 is 96, that means I'm going to need 96. Oh, no, wait. Ooh. Backwards. Check this out. It's how much water should be used with 24 cups of flour. Ooh, not this one. All of that is wrong. Oh, that stinks. I'm not going to redo this video. I just want to let you know I made a mistake. Oh, that's so stinking cool. So this is wrong, so I got to erase that. All right, because I wasn't talking about all this stuff over here. Because what they're saying is they want to know 24 cups of flour. So here's my 24 cups of flour. How much water? Boom, right here. There is my relationship. That with 24 cups of flour, I'm going to have 6 pints of water. So we're going to have 6 pints of water. And then lastly, how much flour per pint? So if you have 1 pint of water, how much flour do you need? And we can see that that is right here. If you have 1 cup of water, you're going to need 4, if you have 1 pint of water, you're going to have 4 cups of flour. So you're going to have 4 cups of flour. So we're going to revisit that tuna casserole recipe from a few lessons ago, and we are given the initial ratio that we have 10 ounces of cream of chicken soup for every 3 cups of elbow-shaped pasta. So we've got 10 ounces to 3 cups, and so we're going to draw a double number line. So let's put the soup on top and the pasta on the bottom, although technically it doesn't matter. And I'm going to draw my double number lines. I'm going to start them both off at 0. And our initial entry is that ratio that they just gave us, which is 10 cups of that soup for 10 ounces of soup for 3 cups of pasta. So there's our initial ratio. And so we know that we could just keep going. So if this is 20, this is 30, this is 40, this is 50. I'm trying to make them equally spaced out. So then what would these bottom numbers be down here? Well, we know that it looks like for every 10 ounces of cream of chicken soup, you have 3 cups of pasta. So 10 ounces, 3 cups. So if you have another 10 ounces for 20, that means you're going to have 6, then you're going to have 9, then you're going to have 12, and then you're going to have 15, and then you're going to have 18. And that is our beautiful double number line. So we're going to answer a bunch of questions now based on that double number line. So if you made a large amount of tuna casserole by mixing 40 ounces of soup with 15 cups of pasta, would it taste the same as the original recipe? Well, here is that 40 ounces of soup, but it would require 12 cups of pasta. So it is not going to be the same. So the answer is no, it is not going to be the same because we're going to have more cups of pasta than the original recipe would have asked for. Number 3 down here, the original recipe called for 6 ounces of tuna for every 3 cups of pasta. Add a line to your diagram to represent the amount of tuna in different batches of casserole. So what we're going to see is we've got this thing. And now what they want us to do is they want us to add, of course they want us to add because I've already drawn it, and so now we have to add it. They want us to add another row, so I'm going to stick it on right here, just kind of right through, and this is the tuna. So I'm going to put a T for tuna, and there's our 0. And it says for every 6 ounces of, they want 6 ounces of tuna for every 3 cups of pasta. So here is my 3 cups of pasta. So that 3 cups of pasta requires 6 ounces of tuna, which means now that I have 6 cups of pasta, how many ounces of tuna? I'm going to need 12. So the tuna is going to go up by 6s each time. And there we go. That is the tuna row. So we actually now have a triple number line to help us with equivalent ratios. Now number 4, how many ounces of soup, let's see if I can fix that, there you go. How many ounces of soup should you mix with 30 ounces of tuna? So where is our 30 ounces of tuna? Well, here is our 30 ounces of tuna, and they're wanting to know how much soup would you need? Well, you would need 15 whatevers of pasta, and you would need 50 whatevers, I think it was ounces, of soup. So the answer is 50. You would need 50 ounces of soup. 50 ounces of soup. And how do we know that? Because our triple number line tells us that. So our brief summary for this lesson is the idea that these double number lines are giving us a collection of equivalent ratios. So if you know the number of eggs, you can simply look up the cups of milk that you need in order to have a recipe that tastes the same. And so let's do a bunch of practice problems, because this is the practice section for lesson 7. So recipe of cinnamon rolls uses 2 tablespoons of sugar per teaspoon of cinnamon. So that is implying the number 1 when it says per teaspoon. So that's talking about 1. So you got 2 tablespoons of sugar for 1 teaspoon of cinnamon. Complete the double number line. Show the amount of cinnamon. So cinnamon is, we can see here that the cinnamon is going up by 1, the sugar is going up by 2. Now, interestingly enough, they list the sugar first, but they put it on the bottom number line. That's kind of interesting. They're kind of getting all sneaky on us. All right, so that's 3, that's 4, that's 5. So the corresponding amounts of sugar is going to be 6, 8, and 10. How did I know that? Well, because I can see that for every 1 cinnamon, we got 2 sugars. So I can see that if you double the cinnamon, you're going to double the sugar. Now I can start to see a pattern that as this goes up by 1, this is going up by 2. All right. So number 2. 1 batch of meatloaf contains 2 pounds of beef and a half cup of breadcrumbs. Complete the double number line. So here's our beef, here's our breadcrumb. So as they want us to go for, what is it? Needed for 1 batch, 2, 3, and 4 batches of meatloaf. So if we're talking about batches, that means our first batch is going to have 2 pounds of beef and 1/2 cup of breadcrumbs. So that's 1 batch. So another batch means we're going to have 4 pounds of beef and 1 whole pound, and then 3 batches, 4 batches, and 5 batches. So there's our 6, 8, and 10. And so we can start to see that as this goes up by 2, this is going up by 1/2. So our remaining values, that's going to be 1.5, that's going to be 2, that's going to be 2.5. And of course, 0 batches is right here. 0 batches, you're going to have 0 and 0 on both of them, aren't you? Now, number 3, a recipe of tropical fruit punch says combine here. So here's our ratio right here, our original ratio. Create a double number line. So they're making us start to do more and more of the work on our own. So here's our first line, here's our second line, and let's do this one is our pineapple, and this is our orange, and they always start at 0. So our ratio that they've given us is 4 cups of pineapple is 5 cups of orange. So 4 cups of pineapple goes with 5 cups of orange. So there is our ratio. So 1 batch, 2, 3, 4, and 5 batches. So that's going to be 4, 8, 12, 16, and 20. Because if you want multiple batches, if you want 2 batches, you're going to have to double the 4. If you want 3 batches, you're going to have to triple the 4 or just keep adding by 4. And so now our corresponding amounts of orange, if you are going to double the amount of double the batch, so it's going to go from 5 to 10. And we could start to see that our orange is going to go up by 5 each time. So that's going to be 15, 20, and 25. Now, they want us to answer some questions. So it says here, if 12 cups of pineapple are used with 20 cups of orange, will it taste the same? So 12 pineapple, 20 orange. So we're going to have to zoom up. Will 12 and 20 taste the same? The answer is no. 20 would be way more orange than the original recipe of 15. So 12 and 20 would not taste the same. So it might taste bad or something. So no, that would not taste the same. And then last, for this part 3, or question 3, the recipe also calls for 1/3 of a cup of lime juice for every 5 cups of orange. Add another line. So 5 cups of orange goes with 1/3 of lime. So I'm going to go up here. And so I'll make it a little bit thicker. And so we're going to add another line. This is for our lime. And it says, oh, and that's definitely going to start at 0. And it said for every 5 cups of orange, it's going to be 1/3 of lime. So right here, this 5 is going to give us 1/3 of lime, which means this is 2/3, because if you double it, if you double the orange, you've got to double the lime, and I can start to see that we are going up by 1/3 each time. So there's 3/3, that's the same thing as 1. That's 4/3, which is the same thing as 1 and 1/3. And this is 5/3, which is the same thing as 1 and 2/3. So that is our addition, our third number line for the limes. As we scroll back down, number 4, 1 batch of pink paint uses 2 cups of red, 7 cups of white. So there is our ratio that we kind of want to be aware of right there. So made a large amount of pink paint using 14 cups of red. So if she used 14 cups of red, how many batches of pink did she make? So if you started with 2, and we ended up using 14, that means we did 7 batches, because it's 7 times the amount. So we did 7 batches. We could make a double number line to count and verify that, but we don't need to. And then it says, how many cups of white would she use? Well, if she started with her 2 cups and multiplied by 7 to get 14 cups of red, that means she's going to start with her 7 cups of white, multiply by 7, and she's going to use 49 cups of white. 5A. Find 3 different ratios that are equivalent to 3 to 1 and 3 to 11, and explain how you know. Well, the idea is we could imagine that double number line, and we could say, well, if it's 3 on top and 11 on the bottom, then it's going to be 6 and 22, then it's going to be 9 and 33, and then it's going to be 9, 10, 11, 12, and 44. And so you can imagine this double number line happening where these entries are corresponding with each other. So there's your bunch of equivalent ratios. And then number 6. Ooh, 6. Is this the last one? Yeah, this is the last one. Woohoo! All right. So here's a diagram that represents the pints of red and yellow. So select all the statements that are true. So this is a little bit of review. The ratio of yellow to red is 2 to 6. Yep. So that's true. So I'll just circle it. Yes, that's true. For every 3 pints of red, you have 1 pint of yellow. Yep, that's also true. And then it says for every pint of yellow, you have 3 pints of red. For every pint of yellow, you have 3 pints of red. Yep, that's also true. And then for every pint of yellow, there are 6 pints of red. If there's 1 yellow, nope, you're not going to have 6. If you have 1 yellow, it's 3. So that's no good. So we're going to cross that off. And then the last one is the ratio of red to yellow. The ratio of red to yellow is 6 to 2, and that is also a true statement.
Woohoo! So that wraps up grade 6, Unit 2, Lesson 7. Students were continuing their work with the double number line to deepen their understanding of equivalent ratios. So if you have any questions, down there in the description box of this video is my email address. Go ahead and send me an email.